Hello and welcome to the video notes for lesson 3.6. You might recall that we mentioned in class you do not have to write any of these notes down on a notes page. You'll actually get the notes page in class tomorrow. But I do want to kind of go over this video so we can go through things a little bit more quickly tomorrow. So I'm just going to kind of go over lesson 3.6. The objective here is to find the distance between a point and a line, and we may also talk about the distance between parallel lines. But really our focus here is this core concept. The distance between a point and a line that's where the point is not actually on that line, obviously, is the length of a segment that is perpendicular to that line from that point. And so what we do is we create a perpendicular segment to line AB from point C, and that is the distance from point C to line AB. And if you notice I've got these other dotted lines, all of these segments that are dotted are actually going to be longer than AC. We can get into a lot of discussion about this. One good discussion is to talk about right triangles. Okay, and I know it has to be a right triangle because I've created a right angle right there. And so let's pretend that I call this point X. And then if this is point X, I get right triangle CXB. I know it's a right triangle because I've set up CX as a perpendicular segment to line AB. And in a right triangle, you remember the Pythagorean theorem where the two legs, if I square those and add them up, I get this third leg squared. Now, we don't have to go through all that work here, but you do remember that this would be the hypotenuse of that right triangle, and the hypotenuse is always the longest side. And since this is the longest side, it's got to be longer than this segment CX. And if I keep on moving that hypotenuse closer and closer and closer, it's still always going to be longer than CX until it becomes actually the same segment. And the same thing works back on this other side. AC, keep moving it back, and it's going to still be longer than CX. And so the shortest distance from a point to a line is that length of that perpendicular segment. Okay, and then also, if a given line and a point not on that line, then there exists exactly one line through the point that's perpendicular to that line. Okay, and it just enables us to be able to set that up. And so what I want us to do then is take a look at this example, and I want you to identify which segment represents the shortest distance from point A to segment DB. Well, we have segment AD, segment AB, and segment AX that all go from point A to line segment DB. But if this is a kite, we know this is a right angle. Okay, we just always have those cross beams intersecting at a right angle. So the segment that is the shortest distance from A to DB is that segment AX. All right, and then this last example that I'm going to cover in the video is how to use this idea in construction. So we have a certain roof truss that is designed so that the center post extends from the peak of the roof, point A, down to the beam. And so what we actually are going to do in class, but I'm going to show you how to do it here, is we're going to do a construction to get that actual segment. And so constructions, remember, are a way of making a very accurate drawing using certain geometric tools. Okay, so we're going to use our compass to help make this construction. So here's what we're going to do. We already have our point A above line RS, and it doesn't quite matter that we have an actual triangle here, but we're going to use that. Okay, and I'm going to set my compass to a length here that is going to cross this line in two different places, not just one, but two different places. So I'm going to try and set this up so my paper doesn't move around too much. I'm going to make that same mark across the line on that side. I'm going to come over here and make the same distance mark here. And so what I've done then is created an arc that crosses line RS at two different places. And so we used a word in this lesson that we haven't defined yet, but hopefully you've done the vocab, and we're going to use that word equidistant. Equidistant meaning having the same distance from. So what we've done is shown that A is equidistant from this point and this point. These are the same distances. So I'm going to use that same setting. I'm not going to change my compass at all. If you changed it, make sure you get it back to where we are now just going to put the point on this point over here to the right of S. And I'm going to make an arc above and below. And that arc's going to go through A. but it's also going to extend below. I'm going to take that same width, I'm going to come over here, and I'm going to make the same arc from this other point. Get that little oval shape in there. And what I've done now is created two intersections of that second arc, and I can take my straight edge and line up these two intersections of the arc, and you'll see that I'm tracing right along that beam that this problem refers to. And this beam creates an exact right angle, and the distance from point A to this horizontal beam on the bottom is the shortest possible distance from point A to the bottom of this truss. And that's how we can do a construction. Now there's a lot of different ways we can do these constructions. I'll show you some other ways in class, but that is kind of what we wanted to focus on. Hopefully this video has been helpful. It will come in handy tomorrow even though you didn't have to take notes over it.